With the gradual failure of Moore's law, the silicon-based semiconductor technology used in smart devices will soon reach its limit. In many new technical directions, graphene chips may be a good choice. For smart devices, after more than 10 years of development, performance improvement is still the most important point for consumers and manufacturers. More specifically, this largely depends on the improvement of chip performance in the device. In the nearly 60 years since the application of Moore's law, the computer has changed from a behemoth to an indispensable portable device for everyone, and information technology has also entered countless ordinary people from military laboratories. However, the improvement of chip performance currently mainly depends on the upgrade of the manufacturing process. As the physical limit is getting closer and closer, the difficulty of process research continues to increase, and the voice that Moore's law will fail is also getting louder. Recently, a number of Chinese companies and institutions have established a graphene innovation consortium. They hope to develop graphene-based chips to replace traditional silicon-based chips. Since the electron mobility of graphene is much higher than that of silicon-based materials, the performance is at least 10 times that of silicon-based chips, and the power consumption can be greatly reduced. At present, many countries are researching graphene chips. Once they are successfully mass-produced, they are expected to break the current silicon-based chip monopoly. In China, various enterprises and scientific research institutes have also been gathering efforts in the field of graphene in recent years. The 8-inch graphene wafer independently developed by China is at the international top level in terms of performance and size. In addition, Huawei's first public graphene field effect transistor patent also marks a new beginning for China in the field of chip research. By the end of 2021, China's graphene patent technology applications accounted for about 80% of the world's total, and the market size of related products has reached 16 billion yuan. So, can graphene chips help China bypass EUV and solve chip problems? I believe you must have seen a lot of rumors about the manufacture of carbon-based chips can completely bypass complex EUV lithography equipment, and graphene wafers will also achieve mass production of carbon-based chips. So, is this a lie? Hi! Welcome to TechTeller. Before we start today's video, please subscribe to our channel, which is the encouragement that we can create more videos. Okay, let's move on to today's topic. Just this month, two flagship processors, MediaTek Dimensity 9200 and Qualcomm Snapdragon 8 Gen 2, were released successively, both using TSMC's 4nm process, but they did not use the 3nm process. In essence, TSMC's 4nm process is actually based on the renaming of the 5nm process node in 2020. This scene actually happened in TSMC's 6nm process, and 6nm is essentially an improvement of the 7nm process node. This means a slowdown in the development of transistor technology. Today, only a few high-end players such as TSMC, Samsung, and Intel are left in fabs that are still insisting on overcoming advanced manufacturing processes. The high chip R&D and manufacturing costs necessary for advanced manufacturing processes have also brought huge cost pressures and investment risks to the company, which has further forced other companies to seek more cost-effective solutions to meet the industry's growing demand for chip performance. In addition, as Moore's law continues to approach the limit, the current silicon-based semiconductor technology will soon hit the limit, and it will be difficult to manufacture 1nm and below processes. Among the many new technological directions, graphene chips are one of the options, and many companies in China have formed alliances to tackle this technology. Can graphene chips help China bypass EUV and solve chip problems? According to reports, graphene is a special material composed of a single layer arranged in a hexagonal lattice of carbon atoms. Its strength is about 200 times that of steel, and its thickness is 1/200,000 that of hair. It has higher electrical and thermal conductivity than copper and weighs less than 1 mg per square meter. At the same time, it also has high electrical conductivity and thermal conductivity, so it has great potential for development in various fields such as heat dissipation, batteries, and chips, and can make data transmission faster, which is also in line with the current development trend of high-performance, low-power chips. At the global IEEE International Chip Wire Technology Conference, graphene was officially positioned as the next-generation new semiconductor material, and carbon-based chips were also defined as the mainstream of the next chip era. However, the manufacturing difficulty of graphene chips is also very high. The industry has been studying the method of mass production for decades, but none of them have reached a practical level. So, can graphene chips help China bypass EUV and solve chip problems? Unfortunately, it can't. Because carbon is relatively stable and easy to form and machine, there have been rumors that the manufacture of carbon-based chips can completely bypass the complicated EUV lithography equipment, and graphene wafers will also achieve mass production of carbon-based chips. However, considering the market, cost, technology, and other issues, silicon-based products will still dominate the industry for a long time. The current carbon-based chips are basically still in the conceptual stage, and there are no finished products that can actually be mass-produced. Similar to the development trajectory of silicon-based chips, if you want to produce and develop carbon-based chips, you must have a complete industrial chain and a large number of R&D personnel that match it, which incurs additional costs. At present, the competition for chip resources in the semiconductor field is very fierce. It is obviously unwise to abandon a good market resource and invest a lot of human and financial resources in choosing a market project that has not yet taken shape. In addition, after comparing the characteristics of silicon-based chips, people may have the misunderstanding that the process difficulty of carbon chips is lower than that of silicon chips. But in fact, if you look at the capacity alone, the manufacturing difficulty of carbon-based chips is indeed lower than that of existing silicon-based chips. This is because carbon-based chips can hold more transistors than silicon chips, and carbon wafers have better transistor overhead than silicon wafers. However, since carbon atoms have 4 free electrons, carbon transistors have high thermal conductivity and electronic activity, resulting in a very unstable internal structure of carbon transistors, which increases the difficulty for chip manufacturers to independently control the resistance and current of chips. This has no effect on small-scale production, but if you want to mass-produce, you need the chip foundry to have the same environment and technical conditions as the laboratory, which is obviously unrealistic. This is why the actual mass production of carbon-based chips is more difficult than silicon-based chips. In addition, the credibility of the rumors that carbon-based chips can avoid EUV lithography machines circulating on the internet is also very low. One of the reasons is that carbon-based chips are only less difficult to process than silicon chips under the premise of the same performance. Like a 10 nanometers process, the performance of carbon-based chips is about 5 to 10 times that of silicon chips. However, no matter what kind of material it is, there is only one way to produce chips of 7 nanometers and below, and that is through EUV lithography. It is undeniable that compared with silicon-based chips, carbon-based chips have great advantages. But at the current stage of exploration, countries around the world have yet to make a real breakthrough in the field of graphene chips. The above is my opinion on graphene chips. Do you agree with me? If you have other great ideas, please leave it in the comment area, and we can have a further discussion. Okay, that's all for today. Please put your comments below, and share your insightful ideas. Please keep following our channel and like our videos. I am Tech Teller, the person to tell you the opinions that worth spreading every day. Thank you so much for your continuous support. Your precious time with us is highly appreciated. See you.